In this problem, we are asked to rewrite the following radical functions to identify their transformations from the parent graph of f of radical x. And so that means that we're looking for a transformational form which involves a, h, and k. So what we need to do is manipulate the equation that we're given so that it will look like a regular K form of a radical. And so to do that, what we have to do is get the A out of the radical. So right now we have something inside the radical that's just not x minus h. We have 4x plus 16. So I don't know exactly what h is. I don't know exactly what a is because it looks a little different from what it should. I actually do know that k is 7 in this case because I have the 7 outside of the radical. And so what I want to do with this is I want to think about the factor, the greatest common factor of the expression under the radicand. So notice that a 4 can go into both 4 and 16. So what I'm going to do is I'm going to factor out that 4 so that I have x plus 4. And then I still have a plus 7. And so what I'm doing here is I'm thinking about that 4 as being a separate thing. So remember that if I'm multiplying inside a radical, if I multiply two radicals together, I can bring them together as one. I can do the same thing and pull them apart. So I can think about this as the square root of 4 times the square root of x plus 4 plus a 7. And so the whole benefit to doing this is that I know the square root of 4 is 2. And so now that tells me that the value of a is 2. And then inside the radical, remember it's x minus h. So since I have x plus 4, that means that our h value is negative 4. And then I still have that plus 7 on the outside, so that means that k is 7. And so what this means is that our graph has the following transformations. So A is a stretch or compression. Since A is a number larger than 1, that means that it has a vertical stretch by that 2. Also, h moves it horizontally left and right. Since h is negative 4, that means this graph is going to have a translation to the left 4. And finally, because k is 7 and k moves it vertically, this is also going to have a translation up 7 units. So this graph has a vertical stretch by 2 and a translation left 4 and up 7 units. Remember that it would be moving to the right if h was positive, moving down if k was negative. And if a was smaller than 1, meaning like 1/2, 2/3, a proper fraction, that would be a vertical compression instead. But strategically, the idea of factoring out the coefficient on x is what we want to do for each of these. So again, we're taking our value of 4 and factoring it out so that we can take the square root of 4. So looking at B, I would factor out a 9 from 9 and 18 so that I can take the square root of 9 for my A to become a 3.